Hello and welcome to the Kentucky Valley Educational Co-op's The Math Corner. My name is Stephanie Kidd and I'm an Achievement Gap Specialist for KVEC. Today we're going to talk about patterns. Specifically, we're going to talk about patterns in algebraic thinking. Patterns are so important in developing algebraic thinking. According to John Vanderwall, algebra is a useful tool in generalizing and representing patterns in our world. Students need to be able to explain the regulations and the consistency across many problems, giving the students to be successful in mathematics. Patterns are both repeating and growing and can be recognized and extended and generalized. Algebra is all about relations. It is representing specific sets of numbers and values. Algebra, you have to see the relationship with each other. You see the sequences that are repeated and the sequences that are based on rules. And a rule is a set of calculations to solve that problem. Algebraic thinking is the study of patterns. Now, when we think about those studies of patterns, we think about many different things. So I want to go into that information today. I really want to talk today about how those patterns in algebra help our students and why we sometimes have to back up and learn about patterns before even learning the rules and the regulations inside of the algebra. Algebraic thinking is a study of patterns, like we've already talked about. But algebra is a part of mathematics. And in that part of mathematics, we have statements of relationships or even relations, utilizing letters and symbols to represent a set of numbers or values and the relationship between those numbers and values. By understanding these patterns, students are able to learn complex number concepts and operations. Students are able to develop generalizations and make predictions. We want to make sure that they understand that. They're also able to see sequencing and those kind of things. So if a student's having those problems, we may have to back up a little bit so that they can understand algebra better. So patterns is our key for this, and we want to make sure that they're understanding it. Now, we also understand that there are different types of number patterns in mathematics. There's arithmetic, there's geometric, there's square numbers, there's cube numbers, there's triangular numbers, and of course there's Fibonacci numbers. In algebra, there are basic laws of algebra. Associative, which is addition and multiplication, commutative, which is addition and multiplication, and of course distributive. Now, these laws explain relationships between number operation and simplifying the equation and solving them. Again, this also involves patterns, and we want them to see that. So to understand this, as I've been saying before, what does a student need to be able to do? See the patterns. So, when we talk about these laws of algebra, and I talk about the associative, the commutative, we may have to back up to this point, and we may have to start talking about what they see. 3 plus 4 was 7, so 4 plus 3 is 7. What do you notice about that? Okay, we're doing the reverse of those two numbers inside. We may want to go back and talk about that in multiplication, and we may even start to talk about what's happening as I add one more number, add two more numbers. Do you start to see those patterns? What does this look like if I'm substituting in for a x in a certain spot? And how does that affect it? And start talking about those functions that you see where I'm putting in what the next number and seeing what comes out. So seeing those patterns is extremely important. Now, the types of patterns we have, there are of course many different types of patterns, and we've talked about arithmetic, we've talked about geometric, we've talked about squares and cubes and those kind of things, but basically it comes down to dynamic patterns and static patterns. Dynamic patterns, they are going somewhere like in music or song, and it'll unfold with time. Dynamic is always extended, and it's indefinite. Statistic patterns are like stripes on the shirt, or patterns like you see the AB patterns, those kind of things. They're patterns that are just kind of set. Now, to establish a rule in algebra, we think about for a number of patterns, we usually involve our ordered pairs, or X and our Y. And we can find that there are different ways for two successive values of Y. And if there's a different pattern in that, and how that coefficient of X in the algebraic rule is the same as the different pattern. So those are the kind of things we want them to get to. But how do I get my student to understand that if they're still struggling? So let's talk about that next. Okay, so what can I do for struggling learners? I want to start out by saying the CSA model. We need to make sure that we're using the CSA model, and they've had a good understanding with patterns using that CSA model. So we're going to have to start out with concrete. We're going to have to start building some patterns, looking at those patterns, and then we'll move over to the semi-concrete where they're drawing out those patterns or even creating those patterns. And this can be done with toothpicks and different things that you can have at home, not just at school. And at school we can probably use graph paper, and we'll build a couple of patterns and then have them extend on to that. But we really want them to build patterns. So using cubes that link together is a great way to start to see patterns. That's wonderful for them. But that's just the beginning of how we're going to see these. So of course, for my struggling learner, I'm going to practice patterns. I'm going to identify a repeating pattern. I'm going to build simple number patterns. I'm going to continue with simple number patterns and determining the missing elements. I'm going to recognize patterns and apply them to the commutative property. I'm going to relate them to addition facts, subtraction facts. I'm going to relate them to multiplication facts. So I'm going to continue to do this, and I'm also going to do other activities that develop that critical thinking and the logic that's needed. So making sure that they've had multiple exposures with multiple different types of patterns so that they can start to see what's happening. The next thing I'm probably going to do also along with that is skip counting and do talk arounds. And I'm going to have activities that build with hundreds charts and number lines. And I'm going to continue a number pattern to match a table or the values. I'm going to have them create tables. I'm going to determine the rule that involves more than one operation to match a number pattern. And I'm going to draw these figures and patterns, and I'm going to write the number that is next to them. I'm going to make sure that we're seeing, not just seeing the pattern, but they're also seeing the number that's associated with the pattern. And this is really, really important for our students. We want to make sure that they are able to see that often. Remember, when you're doing skip counting and talk arounds, you not only want to do skip counting such as forward, but you make sure you want to do it backward too, because that's the addition and subtraction part of the skip counting. The talk around's the same thing. If I'm doing it forward, work it backwards so they start to see that. So making sure that each time when you're doing something with those kind of things, if you're doing multiplication, let's do division. Let's continue to do those kind of things that help to build that underlying part of Algebra 2. So another way that we can help our students with patterns, and most of our teens love music. So if you really want to relate to them, bring music involved and study the patterns in music. As humans, we have this innate thing to actually like music, so we want to make sure that they understand that. Music in many cases have repeating courses or sections of songs. There's math patterns that are used to predict the unknown. We also have, like I said, an innate thing for rhythm and patterns, so bringing that music out helps them to start to see that. Music and math go hand in hand because music is used with fractions and it indicates the length of the notes. And so you may want to talk about the students about the patterns that they're going to see there and being able to see the mathematical symbols inside the music. This is really good for our students to start to see that. And we want to give them something that they're going to connect with. So especially like music and jazz or the melodic patterns that you may hear that can help to motivate them to have to see the repetitive patterns and parts of higher and lower pitch and where do they hear that at. Those kind of things are all there in music, and it's a great way for us to develop an understanding of patterns. Now, what about nature? Man, patterns is all over nature. So let's talk about how we can find patterns in nature. There's a wealth of it. out there for you to extract. And you can talk about the rows and the columns on the floor and the ceiling. You can talk about your desk patterns that you have in your classroom. You can have kids create patterns out of the colored tiles, those kind of things. But let's really think about, where do we see patterns in nature? Well, Fibonacci. Fibonacci's sequence is definitely a pattern in nature. And we can talk about the series of the numbers and how those kind of things, but have students start to look for those kind of things, such as the arrays they see in a sunflower seed and what's going on there. And even other plants, if you look at the seeds inside, there's the Fibonacci sequence. You can talk about how it's in snails, the shape of their little shell. You can talk about the shapes of galaxies and hurricanes, and that's very prevalent to our students today. Even the animal population and plant cell growth and snowflake shapes and the DNA patterns, it's all there. And this is extremely important because our students see these patterns and they understand that, wow, it is all around us. And that Fibonacci's sequence is a series of numbers where it's an addition to the last number. So starting with 0, and then 1, and 0 and 1 make 1, and 1 and 1 make 2, and then 1 and 2 make 3. And it starts out 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. And then you get into writing that expression and how that follows through, and they can see that. So making sure that they understand that. I also talk to them about the patterns that they see in just squares. So I've got 1 squared is 1. 2 squared is 4, but look at the difference between those two numbers. What is it? 3. Well, the difference between 1 and 4 is 3. I also talk to them about the patterns that they start to see. So let's just work this out real quick and let's talk about that and look at that pattern. So I'm going to do this up to 6 squared. And so as we are doing this and you're looking at this pattern, you see that up to 6 squared is 36, and you see the pattern that's in between. This pattern continues, and have them to do that and work through that. It's really important. And like I said, with Fibonacci sequence, I'm going back to that again. It goes with our golden ratio. It's the golden ratio that's explored throughout nature. Like I said, even in hurricanes. But another thing about this pattern that we see is it's great for computer science. And that's a new field that's not really a new field, but it's a blooming field that's here, and it's here to stay because, let's get real, guys, computers are everywhere. So in this, it's extremely important because it talks about the efficiency of data, the structure, the algorithms, and they're based on a sequence that helps to embed the coding and the maximum lengths of the binary codes. So what can I do in the real world also? Well, I can look at trees. I can talk about spirals, I can talk about the waves, I can talk about foams, I can talk about tessellations, I can talk about cracks and stripes. I can even go into discussing the things that are around us in the building of bridges and the patterns that they may see there. So keep in mind those patterns are everywhere you go in the real world. Have them to get out and find patterns. Have them to bring some in, pictures that they may take and give to you. And so if you're doing online, this is really great. Have them to do a nature walk and find you a bunch. Bring them in, send them to you on email, or send them to, or even show it that day and discuss how they see that pattern. So this could be a really good activity that you could do. Okay, I've talked about the CSA model, and I want you to think about that when we're doing this. One of the things with the CSA model is that you have to have different tools, manipulatives, and we want them to communicate what they're seeing, what they know, how they see the patterns, and those kind of things. So it's a lot about building, and then what do I see? What do I know about that pattern? What can I change, or how is it changing? And many times for our kids, they don't want to tell us what they're thinking because they're afraid they're wrong. But if I've built something and I can say, this is what I see, I can start to understand what they're visualizing, and then what do I know from what's changing. And so if they start to see the change, that goes right into function. I'm starting to see that change, and that's very important for our students. So keep that in mind when you're doing these. Another thing I'm going to say is, if you're using the CSA model, I said tools, meaning more than one. So don't give your students just one type of tool to use. You'll want to look at counters, We may want to build with sticks, toothpicks. We may want to build with blocks. So keep in mind your tools have to be multiples along with it. And then of course with the CSA model, we're going to represent that. We're going to draw it out also. One, by writing, we put it into our brain. We're settling it in. So that's another reason why we want to draw that out. So the C stands for concrete, which is my manipulatives, my tools, as I call them. And then the S is my semi-concrete, which is my drawing. I am putting that into print where I can now put it into my brain. And then the A is the abstract, where I represent a number that's going to go with that. Now, when I do this, I don't have to do this all as just concrete, then semi-concrete, and then abstract. I may do this all together at one time. And I'm just letting them see it all. But I may need to just do the concrete and the semi-concrete before I even get to the abstract. That way the abstract's not getting in the way of the understanding that I'm wanting to develop. So keep that in mind when we're doing this. If you want to develop a good understanding, sometimes I have to start with, what do I see? How do I see those changes? And then move on to, how does those numbers represent inside that? So I've done some talking today about things that we can use at school, such as blocks and those kind of things. But I know we're in a virtual world. So right now with a virtual world, what's some things that the students may have at home that they can use? Well, of course, they may have some blocks. But if they don't, they probably have some toothpicks. So keep that in mind. Toothpicks is a good way to do this. They may have some Legos, especially our little boys at home. Or if they have baby brothers at home, they probably have some Legos or some kind of a building block. And then on top of that, paper clips is a real simple, cheap thing that they can use to start seeing that if they need to. Colored macaroni or assorted pastas. And I know that sounds really childish, but to be able to see the patterns, sometimes that's what it takes, is to move back to the very beginning and then start to see those patterns and talk about what's changing. And then, of course, graph paper and graph paper images that are cut out. For your students to be able to cut those images out, to really lay that on an overlay to where it's a big contrast, can help your students to see the difference. So they may have a black countertop or just a black book that they're laying that white sheet of paper on with those squares on it that's marked off, or even put color on those squares to compare it to the white background that's there. Having that contrasting image many times can help them to see the difference in the pattern that's happening. So keep that in mind when you're working with your students. And be creative. Sometimes just being creative with the students, like I said, with the nature walk and coming back and discussing that and having students to discuss what they see in that pattern will help other students to see those patterns also. I just want to take a few minutes to say, hey, thanks for watching my video. And that if you need any information or if there's anything that I can do for you, my name is Stephanie Kidd. Like I said before, I'm an Achievement Gap Specialist for Mathematics at KVEC. And my email is stephanie.kidd@theholler.org. I'll holler at you later.